Hello everybody, my name is Mike Geig. In this video we are going to look at combining the collision detection techniques that we learned in previous videos and kind of see how they relate to each other in a runtime environment. I wanted to make this video for two reasons. The first is to kind of wrap up our conversation about collision detection so that we can see both the bounding rectangle, the distance or radius based collision detection, and the pixel perfect collision detection running simultaneously and see how they affect our frames per second and everything. And the second reason is so it will transition nicely into the next part of this series, which I'm going to be covering game states. So I can kind of do a little bit of work with states in this video, and it'll provide a nice little translation into the next video. What I have here is my shell code, which is a little bit of extra stuff. By the way, if you've been using my shell code since it's been released, I modified it. It's newly updated, so you'll want to re-download that. It has the frames per second available in it now. The only real difference between the shell code and what I have here is this section right here, where I have my sprite struct. As you can see, some things got moved into this new shell variables section, and everything else should be fairly much like we've seen before, except for our update FPS and our drawing. So everything that we're going to draw is going to go under this begin project render section. Otherwise, that should all look pretty familiar. I do have, another thing I have that the shell doesn't have is I have this include math.h and include ppcd.h, which gives us access to our math functions and our pixel perfect collision detection library. Now what I want to do is I want to be able to have multiple objects, basically a collection of objects rendered on the screen. And I want the user to be able to on the fly switch between the collision detection methods so that we can see, kind of how they play into each other. So what I want to do is I want to have basically a rudimentary state system. Alright, and states is basically like a toggle determining how it's going to be functioning at any given time. I'm going to control the names of my states through an enumeration, and everything else is just going to be handled via integer math. So I'm going to have an enumeration, and it's going to be called call state. That's for collision state. And I'm going to be able to have three states. I'm going to have either BR for bounding rectangle, D for distance, or PPCD for pixel perfect collision detection. And those will be my states. Now, since that is an enumeration, that means I can store my states in an integer. I'm going to do int call state, and I'm going to set that, call state. I'm going to set that equal to BR. BR equates to 0, as you can see there, and so my integer call state will equal 0, and that's how we're going to manage that. I also want to check to see if I am drawing my bounding box. We'll do bool bound equals false. I'm also going to do bool collision equals false. You should all be familiar with those from our previous videos. Now, since I said I want to have a collection, I'm going to do constant int num sprites, and I'll set that to start. We'll just do 9 right off the bat. We'll have 9 objects that are collidable, and then I'm going to do sprite ball. I will make that of size num sprites. There we go. Once my num sprites is created, I can go ahead and come on down to my project init, where I can begin initializing, obviously, all my stuff. So I want to, I forgot one thing here. I'm going to come back up here to my project variables here, and I'm going to add a new one. I'm going to add Allegro bitmap orb null. Now, since I just created it here, I'm going to come down to the bottom. I'm going to destroy it. We're going to do al destroy bitmap orb. I want to definitely do that since I keep forgetting in all my previous videos here. Just get that taken care of. And now that that is loaded in here, I can go ahead in my init section and I can say orb equals al load bitmap. And we're going to load in the orb.png that we used in previous videos. Just like that. And then I'm going to go ahead and initialize all of my sprite objects. So I'm going to do for int I equals 0, I is less than sprites I plus, and inside of here I'm going to do ball.image equal ball sub I dot image equals orb, and I cannot type that. Okay, then I'm going to do ball sub I dot x, that's going to equal 100 plus, in parentheses, I modulus 3, because we want 3 columns, times 110, 110 being an arbitrary number that I picked based on the image that I'm using. This just looked good. So those are my offsets, or my offsets and coefficients there. And then it's going to be ball sub I dot y equals 100 plus I divided by 3 times 110. There we go. That'll get my position set up. Then I'm going to do ball sub I dot width, and that's going to equal al get bitmap width, and I will pass in ball sub I dot image right there, and then I'm going to do ball sub I dot height equal al get bitmap height, and once again I will pass in ball sub I dot image. There we go. Okay, this is the part that's going to take the longest during the initialization. We're going to do ball sub I dot mask is going to equal mask underscore new, and we'll pass in ball sub I dot image, and that'll create a mask for us. Now, interestingly enough, since we are using this orb.png over and over and over again, we could technically only create the mask once and just copy it across all of them, because since they're the same image, they're going to be the same mask over and over and over and over again. We could get away with that. I'm not going to in here, because for 2 reasons. One, you won't always have that situation where all the items can share a mask, but that would be a great optimization tip if you did. And 2, I want you to see the overhead of having 9 images, how long it takes to initialize these masks for the pixel perfect collision detection. So just throwing that out there for you. And then I'm going to do ball sub I dot dx, that's going to equal ball sub I dot w divided by 2 minus 10. That's for our bounding box. Remember, I took this from our previous videos. That's where we figured this all out. And then I want to do my bound y. It's going to equal ball dot I dot height divided by 2 minus 20. And then I'm going to do ball sub I dot r is going to equal ball sub I dot w divided by 2 minus 10. Okay, so these values here were all derived from our previous videos, and so that will initialize all of my objects. So fantastic. Okay, so my objects are created and initialized. One more thing I need to do is, before I start getting into my updating and my rendering, is to modify my input. I want to know, basically I want the user to be able to hit 1 to do bounding rectangle, 2 to do distance based, and 3 to do pixel perfect collision detection. So I need some more input statements here. I don't need to keep these in my keys array, because I don't need to know the state of the keys. I simply want to know I simply want to know exactly when the user hits a key, and to work with that. So I'm going to do case Allegro key 1, and if the user hits key 1, I'm going to do call state equals br, and then break. And I'm actually just going to copy this here, and I will paste it 4 times. Oh, I missed the R. I wondered why I was getting my red squigglies there. There we go. And then we're going to do 2, it's going to equal D, and then 3 is going to equal collision detection. There we go. Notice I don't have to note key up, doesn't matter to me. Like I said, I only want it to be a one-time shot. Great, okay. So, that being said, all my inputs are right. Now all I have to do is manage my updating. So first thing I want to do is I want to set my collision equal to false, Now, I can't do what I did before, where either it's colliding or it's not. So I said, if something is true, then collision equals true, else collision equals false. Since there's multiple objects, I can be colliding one with one and not colliding with the other. So I actually have to set my collision equals to false up at the top of my update, and then at the bottom just see if I ended up colliding with something. So you'll see how that works here in a second. So once my collision is equal to false, I'm going to say if key sub up, then I'm going to do ball sub 0. I just happen to know that that's the one I'm going to be able to modify. Minus equals 5. And let me just copy this here. And that's going to be else ball sub 0 plus 5. And then I'm going to say if key sub left, ball sub 0 dot x minus equals 5. And then else ball dot x plus equals 5. Great. So that handles my updating there. And then finally, I want to check to see if I want to render my bounding box. So I'm going to say if key sub space, then bound equals true, else bound equals false. Awesome. Okay, so that's my maintenance stuff there. So let's get to the collision detection stuff. Now, since I now have a variable that will manage my state, like I said, this very primitive state machine I'm using here, I'm simply going to use an if statement to determine what state I'm in. So I'm going to say if call state, call state equals br, and then else if call state equals d, else, like that. I'm actually just going to copy this here and paste it in my render section too, because I'll be utilizing it there. Oh, one last thing. I almost forgot it again. I just happened to look down and see it. We created all these masks, and we're not destroying them, and that's a big memory no-no. So let me come in here and let me do for int I equals 0, I is less than num. Sprites. I really need a note or something like that to help me remember that. I'm going to do mask underscore delete, and I'm going to pass in ball sub I dot mask. Alright, great. Almost forgot it again. Glad I saw that. So let's come back up to my update now that we've done our due diligence there, and we are going to go ahead and do our collision detection. Now, I can't just do a simple if statement because there's more than one item on the table now. So I'm going to say for int I equal to 1. We're starting with 1 because we're controlling 0, and 0 can't collide with itself. So equal to 1. Say I is less than num. Sprites I plus plus. Now, so I don't have to type it all out. You guys might want to just pause the video. I'm just going to copy our code from the previous video. I don't want to have to type that big if statement out, so I apologize. Kind of copping out there, but there you go. The only thing that's different between this and the previous video is that I made it ball sub 0 and ball sub I. So like I said, if you just want to pause the video and type it out real quick there, go for it, but I just wanted to copy and paste, so I apologize for that. Okay, so that is our bounding rectangle collision detection. Left more right than right, right more right than left, up more up than down, down more down than up. Now let's go ahead and do our distance based collision detection here. Same deal. I'm going to go ahead and throw out there a for loop. So for int I equal to 0, whoops, can't collide with itself. I is less than num sprites I plus plus, just like that. I'm going to say float distance equals sqrt, the square root, and I'm going to go ahead and open these brackets up a little bit, and the first one's going to be pow ball sub 0 dot x minus ball sub I dot x, and then we're going to raise that to the second power, so that's going to be our first one, and then I'm going to say plus pow ball sub 0 dot y minus ball sub 0 dot, or I'm sorry, sub 1 dot y. We'll raise that to the second power. Alright, great. And now I can collapse this back down. Once I know that's all set. Alright, so once I have my distance, by the way, that's the Pythagorean theorem. Totally said it wrong in the last video, so there you go. I was programming pretty late there. So Pythagorean theorem, yep. A squared plus b squared equals c squared at its finest. Alright, so I'm going to say if distance is less than ball sub 0 dot r plus ball sub I dot r, then we know we have collision. There we go. Awesome. Alright, and then finally, we just get to do the pixel perfect collision detection looping here. So once again, for loop for int I equal to 1, I is less than num sprites I plus plus, and I'm going to say if mask underscore collide, and I will pass in ball sub 0 dot mask, and then ball sub I dot mask, and then ball sub 0 dot x minus ball sub I dot x, comma, ball sub 0 dot y minus ball sub I dot y. Just like that. Then we know collision equals true. Awesome. That's a lot of typing. I'm going to build this, make sure I didn't type anything wrong. Fantastic. We've built. So basically, these are the three algorithms we saw before, only now they're in a for loop and they're inside our different states. Alright? Truly the only difference there. Great. So now all I'm going to do is I want to start this section here by drawing all of my images. This one's pretty easy. I'm just going to do for int I equal to 0, I is less than num sprites I plus plus, and I'm simply going to do al draw bitmap, and I'm going to draw ball sub I dot image, and I'm going to do ball sub I dot x minus ball sub I dot width divided by 2, and ball sub I dot y minus ball sub I dot h divided by 2, and no flags. Just like that. Okay, so that'll draw all of our images on the screen. And now the reason we want to have this here, our states, is to determine the bounding rendering, the rendering of the bounding box. So I'm going to say if bound, I don't need to do if bound equals true, I just need to do if bound. Put all this inside that if statement there, just like that. And then I have to have, and I'm just gonna copy this for loop, so I don't have to type it out 3 more times. So if our call state is bounding rectangle, I'm going to do for int I. Okay, and so what I'm going to do, and you guys can just pause the video, is I'm just going to go ahead, I'm just going to paste this. This is what we saw in our previous video with bounding rectangles. Only difference is I substituted the ball sub I for this, so I'm just drawing the upper left hand corner and then the lower right hand corner, and then I'm drawing in our faint magenta color. Nothing really new there, so go ahead and pause the video and just copy that if you want. And then I'm going to do the same thing for my distance-based collision detection. I'm simply going to do, let me copy this for loop, paste that there, and I'm just going to go ahead and grab the code for this and just reuse it so I don't have to bore everybody with typing out every little thing. Once again, just using the updated wording for the new objects. And then finally, for my mask, I'm just going to go ahead. This one's actually pretty simple, but I'll still just copy and paste here and go boom, like that. Okay. And so we have the bounding getting drawn, the bounding objects, either bounding boxes, bounding circles, or bounding objects, depending on our collision state, ours now all being drawn correctly. And then finally, we just need to say, hey, if there is a collision, we want to go ahead and do AL draw text, and I'm going to pass in font 18, and then AL map RGB 255, and we'll position that at width divided by 2, and then our height will be 20, and we'll do Allegro align center, and then it will just say collision. Fantastic. Okay, so I know I copied and pasted a lot there, but I just kind of wanted to speed this video up. Let's go ahead and run it. Now we're going to spend a while waiting, so now we got to build 9 masks. It took about 2.5 to 3 seconds to just do 2. So you see, building these masks does take a good amount of time. And there we go. Awesome. Obviously I did something wrong because my image just shot right off the screen there. Let's go ahead and see if I can't fix that. So let's go ahead and scroll up here. Oh yeah, and right now way I see, I'm just doing if else. So if I'm not holding up the up key, the ball is going to move down. That was silly. So I actually need to do else if keys sub down. Whoops, I apologize for that. And then here I need to do else if keys sub right. Like I said, my coding prowess is a little off tonight, so let's go ahead and run this again. Unfortunately, now we're going to have to wait through this loading time again. Like I said, if you're using a game where several images are the same, and you want to do pixel perfect collision detection, your best bet is to copy masks because they're going to be the same. And so here we see, I'm going to hold down my space, you can see my bounding boxes, using bounding box collision detection, no impact on my frames per second here as I'm rendering collisions. You see that's all behaving very accurately, so great. Okay, so let's switch up here. I hit the 2 key, and now I'm doing radial collision or distance-based collision detection. Once again, not affecting my frames per second, so working out rather well there. Great. Now you're going to notice something very interesting. When I switch over, to my the pixel perfect collision detection, which I just did, right like that, my frames per second, did you see that? They dropped down and they shot up. Watch, I let go, we come back to 60, I hold it down, boom, down to 58, back up to 65, right? So basically, my game loop starts acting very irregular, basically due to the load of